Hello, everyone. Good morning, good afternoon, and good evening. Thank you so much for joining us here today. My name is Carlo Bobilas, Community Manager over on the Cisco Learning Network. If you are tuning in but have not officially registered for the program, I highly encourage you to do so by scanning the QR code on your screen. It'll be a good way to be notified of upcoming live streams and be informed when they are available on demand. One important note regarding Slido is that participation for Q&A is exclusively for the live audience. So if you're catching this session on demand at a later time, the Slido QR code might not be active, so just something to keep in mind. And if you haven't done so already, you can log in to Slido by scanning that QR code on the screen with your mobile device or by logging in directly through our live stream page. Without any further delay, I'd like to introduce Technical Marketing Engineer, Technical Leader, Young Lee, to give a few words. Young, over to you.
Thank you, Carlo. Hello, everyone. Welcome to another Cisco Learning Network technical webinar. Thank you all for joining. This is the third installment of a four-part series on Cisco Secure Firewall, Threat Defense, SD-WAN capabilities, and use cases. In this installment, we are going to discuss direct internet access feature at a branch, leveraging policy-based routing capabilities of the FTD platform. My name is Yung Lee. I am a technical marketing engineer from Cisco Validated Team. Co-presenting with me today is my esteemed colleague, Dinesh. Also on the line with us are several of our colleagues from my team, as well as from Cisco Security BU, who are joining as Q&A panelists to help answer your questions during the webinar. At this point, I am going to turn it over to Dinesh to say hello. Please take it over, Dinesh.
Sure, Doug. Hey everyone, this is Dinesh. I'm one of the technical leader with the Firewall business unit. And along with Dung, we're going to run you through the third webinar for our series. So let's get started. So in today's agenda, we're going to talk about the direct internet access capabilities and how we do the configuration. And along with that, Dung is going to walk you through a live demo for the solution. So let's get started. Before we dive in, let's set the premise and talk about how do the traditional networks work, right? So what you will notice is that in a traditional network, we have branch sites that have VPN tunnels all the way back to their hub setup. And this is where all the traffic that is coming in from the branch sites is being sent to the corporate network. Now, whether the users in the branch need to go out to the internet or whether they want to access the resources off of the hub site. Now, this architecture is based on backhauling all the traffic. And the challenge is this leads to poor user experience because the hub site is now doing all the processing and inspection, which kind of increases the packet latency and drops and the jitter as well, right? Now, there are various ways to address these challenges. And one of the way is direct internet access. So this is where we're moving away from the traditional deployments and providing a capability for the branch users to directly go out to the applications through the branch internet path, rather than backhauling all the traffic over to a centralized site. This results in reduced latency and provides improved user experience. And this is achieved with the help of what is called policy-based routing, or what we also call as application-aware routing. All right. So in terms of the capabilities, the core theme of direct internet access is to be able to route the application traffic directly out via the ISP links on a branch site. Now, there are various ways to do it. The one way is that you can route this traffic based on the source IP, which is supported on the Secure Firewall 7.1 release and above. And along with that, the 7.1 release also supported application-aware routing, where you can send the traffic based on a specific application, and that can be sent out directly to the internet. Now, with the 7.2 release, we added what is called path monitoring for the application-aware routing, which we will talk about in detail in the next slides, and also supporting ICMP, and the HTTP-based path monitoring. And lastly, we support SDT-based or your user identity-based policy-based routing with 7.4 release and above. Now that we know what are the capabilities, let's talk about how the direct internet access helps. So here are some of the key reasons how direct internet access really helps with the deployment. So all in all, it reduces the latency, packet loss, and the jitter, which is associated to backhauling all the internet traffic to your central site or a hub site for the inspection. And of course, because you're not sending all the traffic to your central site, it is reducing the bandwidth usage. And because the direct internet access is allowing a smoother transition to the internet for the SaaS applications, that improves the internet speeds as well as branch user experience. Now, what stands out in this deployment is that now you will have a best egress path, which is guaranteed without any manual intervention, where an admin doesn't have to go in and change the path for the applications. And along with this, we also get what is called continuous monitoring of the link health, which means that if your link is not performing well, the application can be steered to a next best path. And if the other path becomes better, it can be steered back again. Okay. So with this, let's see how it works. So initially, the user initiates a DNS request for a particular application. And this could be destined to a trusted DNS server, which the firewall is connected to. Now, the premise here is the firewall should be able to see this DNS request because the firewall uses what is called DNS snooping to see the domain name request and also map the DNS request to the corresponding domain and the IPs. So in the step 2, the firewall snoops the DNS response and stores the domain information. And with step 3, it goes ahead, the user initiates the traffic and is sent out through the policy that you have configured. Now that we have defined how the traffic can be steered to a certain ISP or certain internet path based on the configuration rules, what's important here is to also ensure that the path that we have selected remains the best path. So to augment this capability, we added path monitoring, where we have intelligent application routing based on what is called as a dynamic path metrics. These metrics are nothing but round trip time, packet loss, jitter, and mean opinion score. And the way this works is where the firewall is going to initiate ICMP probes or the HTTP probes. And then based on the response, it is going to calculate the dynamic path metrics, and those metrics are going to be used to send the traffic over to certain SaaS applications. So a typical deployment could be where you might have, for the WebEx traffic, primary path, which is through the ISP link. And if those dynamic path metrics become better on the ISP2, then you can send the traffic through the ISP2. And likewise, if you have traffic going to the Splunk, which might be using ISP2 as the primary path, if the metrics for that path become worse than compared to the ISP1, then the traffic will be transitioned to the ISP1. Now let's talk about how IP-based path monitoring works in detail. So what we have is called path monitoring module. The role of this module is to collect the link metrics using the ICMP probes. The link metrics being the RTT, jitter, packet loss, and the MOS. Now, this ICMP probe is sent every second. And then we have the policy-based routing module, which is used to route the traffic based on these metric information that we get from the path monitoring module. So the workflow is like this. Initially, the path monitoring module is going to send the ICMP probes to the monitor destination. Then once we get those stats, these stats are actually stored in the database. Now, along with this, the path monitoring module is also going to send the list of the interfaces that we have to the policy-based routing engine. That's the engine which is actually going to route the traffic. Now the policy-based routing engine has the information about the interfaces from step 3. It also fetches the metrics from the internal database in step 4. And lastly, based on the interfaces and the metric information, policy-based routing engine pushes the routing updates to the data path, which is the actual component responsible for sending the traffic. So for example, if you notice, the ISP2 round trip time is lower than the ISP1 round trip time, and this information is in the database, which is sent to the policy-based routing engine in order to allow the traffic to be sent via the data path. Now, similarly, we have HTTP-based path monitoring. Now, in this, we have something called HTTP client module. This sends HTTP probes to the monitored domains, or in our case, applications, and then forwards the response back to the path monitoring module. So this path monitoring module is common with what we saw on the last slide with the ICMP probe. And the role of the path monitoring module is the same, to compute and store the metrics, whether they're coming from the ICMP or HTTP probe. The last piece of this puzzle is policy-based routing engine. So now the path monitoring module is going to send this information to the policy-based routing engine, and then policy-based routing engine is going to route the traffic using the egress interface as per the best metric, which was reported by the path monitoring module. Now, please note that the application monitoring probing interval is 10 seconds. So with every 10 seconds, we are going to probe the destination or the domain that we are tracking, and then fetch the details and send it to the path monitoring module. Now, let's see how this works in details. So first of all, the HTTP client module is going to start application monitoring when a DNS entry is snooped in. As soon as we get the response, the path monitoring module is going to store the metrics in a database, and also going to push the metrics, which are per domain and the egress interfaces, to the policy-based routing engine every 30 seconds. Now, as soon as that is done, the policy-based routing engine has the information about what are the egress interfaces, what are the metrics associated to it, and based on the policy configuration done by the admin, it is going to push the routes into the data path, and that allows the traffic to go through. Now, in terms of how the user experience looks like, the user initiates the DNS request for any particular application. So for example, if you notice, we have a rule that says if you want to access Splunk application, send the traffic through the ISP1 and ISP2 or outside 2 based on minimum jitter. Now, the user is going to initiate the DNS request for the application. As soon as the firewall sees this DNS request, it is going to look for the response coming in from the DNS server, and it is going to store the information and the corresponding IP address and the domain into its database. Now, with the step 2, the trusted DNS server has responded, and the branch user has got the DNS response. And now the firewall, given that it has the domain information, it is going to trigger the HTTP client module to send the HTTP probes. And these probes are actually going to the applications that we have configured. Like in our example, it's Splunk application. Now, as soon as we send the HTTP probe, we get a response, and then we compute and store the metrics, for example, in this case, jitter, into the database. And lastly, because the firewall has the information about the interfaces as well as the dynamic path metric, which is jitter, it allows the traffic based on whatever is the best path based on the jitter. Now, extending this capability beyond the IPs, networks, and the applications, with 7.4, we also support application-aware routing, and we make it identity-aware as well. What that means is, with the 7.4 release, now we can have user identity or the AD group, or even security group tags that can be used as a condition within the policy-based routing configuration. This really shines in a deployment where you have segmentation and you want to use user identity or the security group tags for maybe some guests, some contractors, or some IoT devices, and then send the traffic through the best path possible. Now, this does require integration with the Microsoft AD and Cisco ICE. Uh, in this context, you can use Cisco ICE to get the security group tagging and use that. But if you do not have ICE integration, you can use security group tagging manual configuration on FMC as well. Now, this is how a typical deployment looks like, where you have ICE integration and the Active Directory integration. So the Firewall Management Center, which is the management solution to configure the firewalls, it gets the information like user login events and security group tag info from the ICE, which is our identity and access server. From the Active Directory, we get the user and the group association. And this information then can be leveraged to create the policy-based routing rules to allow the traffic through certain internet egress path based on the user group, user identity, or the security group tags. Now that we've talked about what are the capabilities, let's talk about how we can provide increased usable bandwidth for the applications and the users that are trying to access those applications. So Secure Firewall starting 7.0 release supports something called equal cost multipath feature. This allows traffic to be sent from multiple paths in a form of active-active load balancing. And this is supported today on the physical interfaces as well as your virtual tunnel interfaces. And as you notice, if you have multiple interfaces, the ECMP support is available today up to 8 interfaces, whether they are physical or virtual tunnel interfaces. Now, before we get into the configuration, let's talk about what are the fundamental blocks in terms of configuration for the direct internet access or policy-based routing. So we start with Trusted DNS Server. Now, Trusted DNS Server is a component which you as an admin are going to configure. This allows the clients to send the request to a known trusted DNS server, and the firewall is going to intercept and look at that DNS request and response and deduce the application that the user is trying to go to. This is really important before we do any policy-based routing or application-aware routing configuration, because we want to make sure that the users are sending the request to a known and trusted DNS server and not a rogue DNS server. Now, in order for the firewall to identify the applications or map the domains to the applications, this is done with the help of vulnerability database. This provides us a list of mapping for the domains and the applications which can be detected using direct internet access. Now, beyond this, you have something called network service object and network service group. So when you configure the policy-based routing using the applications or the security group tag, what the firewall does is it creates what is called network service object, which is mapped to a particular application. And if you're mapping or if you're sending the traffic to group of applications, it creates what is called network security group. Now, the network security object and the network security group, they're both configured automatically by the virtue of the admin configuration on the FMC, while the trusted DNS server needs to be configured manually, and the vulnerability database can be downloaded automatically or can be scheduled to be downloaded automatically. So now that we know how the direct internet access works and what are the main components, we'll jump on to the direct internet access configuration, and I will hand it over to John for taking it away.
Thank you, Dennis. Hello again, everyone. So now let us take a look at the policy-based routing configuration. First, we're going to take a look at how to configure ECMP zone, because that is an important of the configuration, and you couldn't do that under device. device management, routing page, ECMP, and then from there you can configure your ECMP zone. We'll walk you through a live demo in just a little bit. Next, you need to make sure that the path monitoring is enabled. And you can do that under the device interfaces configuration page. Ensure that the path monitoring is enabled on all interfaces. Next, we need to configure the trusted DNS server. And we can do that under the platform setting, threat defense settings. And here you can specify one or more DNS trusted servers. Next, you need to configure the extended ACL. This extended ACL is used to identify the application traffic of interest, and you can do that under Objects, Object Management, Access List, Extended Configuration page. And lastly, you will need to identify or configure your policy-based routing. And you do that under Policy, Device Management, Routing, and Policy-based routing. Now, the configuration have several items that you can configure. First, you can configure the interface priority. This is optional. You only need to do this if you want to route based on interface priority. Next, you need to select the ingress interfaces that you want to apply the policy-based routing to. Next, you need to select the matching ACL that you created in the previous step. Then select the ordering option. There are several that you can select. You can select based on interface priority, route trip time, jitter, packet loss, or MOS value. MOS stands for mean opinion score, which is a way of rating the voice quality. And then you need to identify the egress interfaces. Here is the PBR order of operations. Just like ACL, the packet is checked against the PBR policy in a top-down manner and uses the egress setting based on the first match. As such, it is recommended that if you have a complex PBR policy, make sure you put the more specific at the top and the less specific or more general toward the bottom. When you add a new entry to the PBR policy, it is added to the bottom of the policy. You can drag and drop the entry to reorder it in the way that you want it to look like. Now, one thing important to note that if PBR is not able to find a match, it will fall back to normal routing. Now, you can also configure the ACL with a block action. The block action basically say fall back to normal routing. So make sure your normal routing is working as expected. Here are a list of verification commands and some troubleshooting commands. Also, we'll use the UI to show you some of the displays that can be useful in observe how policy-based routing work. Okay, we're not going to walk you through all of this, but we'll show you a number of the commands a little bit later on during the live demo. One note that I want to say here is that just like any debugging, right, make sure you proceed with caution when you run a debug commands, because some of them can have a very verbose output, and it could be negatively impact the performance of your production network. Now let's get into the demo, right? Here's our topology reference diagram. For those of you who have joined us in the past, we have used this in previous webinars to build the overlay, right? So let me take a quick walkthrough of this to show you what we have. At the top, we have our two hub sites. On the left here, we have New York hub, and on the right, we have New Jersey hub site. In the bottom, we have our branches. In this particular use case, we are going to focus on WMA branch for the policy-based routing, because it has two egress interfaces or two WAN interfaces that allow us to demonstrate the capability. In the middle, we have our two ISPs. We have ISP1 and ISP2. And in the previous webinar, we already built the overlay on top of these two ISP already. From a release perspective, we are running release 7.6 for both the FMC and the FTD. Now, you might want to take a screenshot of this diagram for your reference as I go through the configuration and the verification a little bit later on. Here is the double click into WMA branch. Okay. Now let's talk a little bit in details about this branch. Here we have the FTD platform here. We have two ISP. We have ISP1 that uses this DHCP, and we name it with a logical interface name called outside one. On the right, we have another ISP link. We name it outside 2, and it uses this static IP. We wanted to be able to use both of these for our direct internet access based on various use cases that we listed here on the left. We'll walk through it in just a little bit. On the inside, we have one interface to the LAN side. We name it inside dash employee. On our LAN side, we have a Windows client with the IP address of 10.72.120.50 that we are going to be using for testing purposes. From the SD-WAN overlay perspective, please remember that we have two hub sites, but for simplicity, I'm only showing one hub site here. I'm showing New York City hub site, right? Between the branch and the New York City hub site, we have two virtual interfaces. And again, we wanted to be able to ECMP across both of those for the internal apps. In this case, we put in a couple here just as an example. For example, we have an internal website, and you can also use it to SSH and etc. And we have a sample server here with the IP address of 10.100.0.5 that we're going to be using a little bit later on. From a use case perspective, we identify several types of SaaS application. The first group, we call it cloud storage apps. In this case, we identify two. box and drop box. And for use case 1, we wanted to route based on interface priority. So we are going to be setting the outside one to priority of 10 and outside 2 with a priority of 20. The lower the priority is the preferred metric. So with that in mind, with PBR, once the IP cache and all of that being populated, the traffic for cloud storage apps such as Box and Dropbox should be using ISP1. Until ISP1 is down, then it's going to use ISP2. In use case number 2, we have a group of media apps, social media apps. We identify 2 of them. One is Facebook, the other one is Instagram. And we wanted to route based on dynamically calculated route trip time with minimal being preferred. Okay, you're going to see how that works when we go through that. In the third use case, we have conferencing apps. We identify 2, WebEx and Zoom. And because conferencing app is typically pretty sensitive to jitter, so we're going to route based on minimal jitter. Okay. And last but not least, we have internal corp app here that we're going to load share across the 2 VTIs here. Now I'm going to park here for just a moment. If you like to take a snapshot of this screen so that you can use for reference while I go through the configuration. All right, so now let's switch over to our FMC interface. Here are our devices. On top, we have the hub side, and on the bottom, we have our branch side. In this particular use case, we are going to focus on WMA site or branch, right? So the first thing we're going to do here is we're going to need to check the ECMP configuration, right? In the interest of time and to avoid typo, I already configured a couple of them. So you go to navigate to routing tab. Under routing tab, you will see ICMP over here. You click on it. You will see that we already have 2 ECMP zones defined. The first one is, I call it ECMP WAN. We have outside 1 and outside 2. We needed this in the previous webinar in order for us to use both of those interfaces to configure the default static routes so that we can establish our SD-WAN overlay across both of those interfaces. So it's already configured. And once we have the overlay up and running from the perspective of this particular site, because we have 2 interfaces and we have 2 hubs, as a result of that, we have 4 virtual interfaces: VTI 1, VTI 2, VTI 3, and VTI 4. And we wanted to be able to load share across all 4 of those VTIs. So here we created another ECMP zone called ECMP-VTI. But only 2 of these VTIs going to terminate at the New York hub, one based on the ISP1 and the other based on ISP2. And the other 2 will be terminated at the New Jersey hub site, one's on ISP1 and the other one on ISP2, right? So this is important. Next, we need to check to make sure that the path monitoring is enabled on the interfaces. So we go to interfaces here. Here, as you can see, we have Ethernet 1.1 identified as outside 1 and Ethernet 1/2 as outside 2. And these are the 4 tunnel interfaces that I mentioned previously. 2 on Ethernet 1.1 and the other 2 on Ethernet 1/2. Okay. To configure path monitoring, we need to edit the physical interface. Right here, you see path monitoring. We'll click on here. You can see that HTTP base, as DNS were mentioned earlier, already enabled for you. However, you can see the application down here is currently empty. It will be populated once we use the ACL to identify the application of interest. Okay, we'll see that a little bit later. Now, we also have IP-based monitoring. As Dennis mentioned also, this is ICMP-based, and you can enable it if you choose to do so by clicking on this. Now, when you do that, the auto option here will allow us to monitor the interface default gateway, which is the next hop IP on this interface. Now, that is not very accurate, right? Because typically that will be just your ISP uplink, right? Your ISP router. So you can also monitor based on a peer IP address. So for example, if you choose that, you need to enter a peer IP address. Now, making sure that peer IP address is pingable so that we can collect the statistic in terms of packet loss, jitter, delay, so that we can derive the average calculation as we mentioned earlier, and we can also calculate the MOS value. Okay, so let's just, as an example, we'll go with A.A.A.A. Okay, click on OK. Now we need to do it for both interfaces. So we'll do it for the second interface here as well. Right, you can see when you make the changes, you will see save the changes here. I like to save it periodically, so I'm going to save it for now. Okay, so that's the second step. The third step is we need to make sure that we have trusted DNS servers defined. Right, to do that, I am going to navigate to. But before we do that, actually, I'm going to show you that before we can configure the trusted DNS server, we need to configure what we call the host object. To do configure the host object, we need to navigate to object management, right? From here, under the network object here, we already have a couple created. So here, we're going to search on it, and you can see here we have 2 internal DNS server host object created here. Okay, and we also have 2 external DNS server configured. These are basically umbrella DNS servers. Okay, so that already created. Now to identify the trusted DNS server, we need to navigate to devices, platform settings. Now, initially, you will not have the threat defense setting configured. You need to configure one by clicking on New Policy, Threat Defense Setting here, right? In the interest of time, I already have one defined here, okay? So we'll go ahead and edit this. We'll go under DNS here and Trusted DNS. Here you can see I have identified the 2 internal DNS servers as well as the 2 external DNS servers here. Okay, and this policy is assigned to WMA branch. All right, so that's the third step. The next step is we need to configure extended access list to identify the application of interest. So we go to object management, and on the left here you can see access list. We'll expand that. We'll select extended. To add an extended access list is pretty easy. Click on add. Here you give it a name. And then here you can add one or more access list entry, right? By clicking on add. And we have the ability to match on the traditional 5 tuples, source, destination IP, source, destination port, and protocols. Okay, or we can match on application. Here we give you a list of application in that database that Dennis walk you over, right? Here you can identify the application interest. For example, we want box. We type in box, and you can see here box show up. Okay, you just select it and add it to over here. Now we can also identify based on user identity, which require integration with Active Directory. And we can match based on security group. We can optionally integrate with Cisco ISE to get that dynamically, or we can statically define the security group tags. Now, we have a use case in the next webinar that will showcase how you can use the security group tag in policy-based routing. Okay? Now, once you add one or more entry, then you can click on add to create that extended access list. We already have a couple identified, so I'm going to cancel out here. First, we have the Cloud Storage App ACL here. Just take a quick look at it. Pretty simple. We allow from any source, any destination to application box and Dropbox. Okay. Similarly, we have the social media apps. In this case, we identify Facebook and Instagram. And we also have one we call conferencing app. We identify WebEx and Zoom. And our internal corporate app. And in this case, we're actually using the traditional tuple, source, and destination IPs, and the application ports that destination application port that we target. All right, so the ACL is created. Now we will perform the last configuration step. For that, I'm going to switch back to here. And we are still under WMA device configuration. I'm going to navigate back to routing. Under routing, you will see here that we have policy-based routing. You click on it. We don't have anything defined just yet. Now, if we want to route based on interface priority, you can configure the interface priority here. As you can see, the default priority for all interfaces, physical or virtual, is by default 0. Okay? You can configure the interface priority here, or you can configure it under the interface itself, right? So For simplicity, I'm going to go ahead and configure it here. For outside one, we say we wanted to configure it as 10. And for outside 2, we're going to configure it as 20. We'll save that. And we'll save this for now. Next, what we need to do is we need to add the policy-based routing policy. We click on Add. We will need to identify ingress interface because PBR is an ingress interface type of feature, right? So here, remember our inside interface is inside-employee. We'll select that. Then we need to add the match and egress interfaces. To do that, we click on Add. The first thing that we need to do is we need to add the ACL to identify the application of interest. Here we will start with Cloud Storage Apps ACL. Here you can say send to, the default is egress interfaces, but you can also send to the IP address too, right? We'll keep the default. Here you have the opportunity to identify how do you want to route the traffic, the criteria, right? The default is interface priority. You can also use the order. The order is similar to interface priority. The order, whatever the interface you put first will be used first, and then the next one, and so forth and so on. Minimal jitter is based on the dynamically calculated metrics that we collected either through ICMP base or through application base. Now, if you have both, the application base will take precedent because it's more accurate. Okay? And then you can also route based on maximum mean opinion score. As I mentioned, it's used to kind of like evaluate the voice quality. And it's a combination of jitter, packet loss, and route trip time. It's a very complicated formula to derive the MOS score. Okay. And you can route it based on minimal route trip time or minimal packet loss, right? So for the first use case, we're going to stick with interface priority. So I'm going to leave it at the default here. Now we need to identify which interface or which egress interfaces that we wanted to use for this particular entry, right? So we are going to use outside 1 and outside 2. These are two underlay interfaces, right, for DAA use case, right? And you can see here priority 10, priority 20. We'll save. Now we have our first policy-based entry. To add another, you can simply click on Add here. Again, we need to identify the ingress traffic. And next, we're going to say social media app. We're going to leave it at the egress interfaces, and we are going to route this based on route trip time, right? And we're going to select the egress interfaces. In this case, outside 1 and outside 2. We're going to say that. We're going to add one more. Here is going to be for conferencing app. We're going to route it based on minimal jitter and outside 1 and outside 2 again. Right? And the last one we're going to add here is for the internal apps, corporate internal apps. We're going to leave it at the default interface priority, and we want it to route it across our VTI. In this case, VTI 1 and VTI 4 terminated at New York City. So we're going to select these two, right? You can see here the priority is default to 0, meaning that we are going to load share between the two interfaces. So we're going to save this. Now, as mentioned previously, when you add an entry, it will be added to the bottom here. But you can actually drag and drop them in any order that you would like, okay? For this, we keep it like the way that we have it, okay? But you can drag and drop them like so. Now, just kind of quickly read this so we can kind of all understand, right? If we are matching the cloud storage app, ACL, we're going to send the traffic through outside one. If that interface is no longer available, then we send it to outside 2. In the second use case, we are going to route it through these two interfaces based on the minimum dynamically calculated route trip time that we derived. In the third use case, we're going to route the traffic out outside 1 and outside 2 based on minimal jitter, dynamically calculated again. And for corporate app, we're actually going to load share between both of these VTIs. Okay, now if everything is looking good, we can click on Save. And here again, you have the opportunity to review them one more time. And then we'll need to save it. And the last step here is we're going to need to push the policy, right? Or deploy the policy. We're going to deploy it to WMA. Now, the deployment of the policy will take just a minute, right? Once the deployment is finished, I'm going to show you a few of those verification commands on the COI. I'm also going to show you a couple UI on the FMC that we can use to observe the traffic flow. Okay, now to be totally transparent with you, because we just pushed the policy, the behavior on the UI might not reflect exactly as we intended, because it does take a little bit of time for the database, particularly the IP cache database associated between the domain name of the applications and the IP addresses to build up. And also for us to see the traffic from our HTTP probes so that we can calculate the dynamic value in terms of minimum average RTT, average jitter, and so forth and so on, in order to prime the PBR module. Okay, so you can see the deployment is completed successfully, right? So before we generate any traffic, let us navigate to the device, right? We're going to click on COI here. And let's just do a couple show command, right? First, we can show run interface. Here are the two underlay interfaces. You can see that we have the policy route cost of 10 for the first interface here, policy route cost of 20 for the second interface, okay? You can also see here that we have a number of policy-based route command here, right? With some objects that we identify for monitoring. We'll take a look at that next, right? And you can also see that we have an ICMP-based monitoring going to A.A.A.A. All right. Next, we're going to do is we're going to take a look at the DNS configuration, right? We have our trusted DNS server defined here. We have 2 internals and 2 external here. Okay. Next, we're going to take a look at the route map that automatically generated for us. All right, you can see here, based on the name here, there's one route map that used to identify the ACL, right? Another one identify social media app ACL. Another one for conferencing app, and the last one is for our internal app. Okay. Now, if you want, you can take this and you can say show run access list and the name of that ACL. And this is the ACL that we identify, right? And this is the dynamic object group that being created, right? We'll copy that. We'll do a show run object group and the network service, and that object, I'm sorry, should not be show run, it just show object. There it is. Okay. We dynamically identify box and drop box here. All right. Now let us show you the UI that can be used for monitoring purposes, and then we will generate some traffic. Okay. For that, we can navigate to analysis, unified events, right? Now for this, we can basically, identify what we want to see here. One of the one that really important for us is the web application and the egress interface in this case, right? Now, at this moment, we haven't generated traffic yet, so we'll come back to that a little bit later. We also want to show you another interface that is useful to observe the traffic. We can go to overview, dashboards, SD-WAN summary. And from here, you can see that we have application monitoring. We can click on it and select the device of interest, in this case, WMA. And you can see here that we have ICMP-based monitoring, already populated with some average jitter, route trip time, packet loss, and calculated mean opinion score. Okay, down here you can see the comparison between the values. Okay, now what we have not seen here is the application of interest that we are identify, right? Now it will take a little bit of time for us to see the DNS snooping, to cache the domain names and IP addresses, and to see enough traffic so that we can calculate and see enough of the HTTP probes, so that we can calculate the values. So be patient, it's going to take a few minutes for this to be populated after the traffic is seen. right? So everything is good here. So what we can do is we can go back over here. Oh, one more command I want to show you before we do that. Another very good command to show is show path dash monitor. Okay, here you can see we have the object group, the network service group that we identify on the interfaces, right? But we have not really seen anything yet. We only seen the ICMP based one, right? That is because we have the FTD platform have not seen the application yet. Okay, so let's go to our client here. Here you can see the client is 10.72.50, which is this client here. Okay, and here you can see the two DNS server that we identified. Okay, one internal and the other one external. Okay, these are the application that I, for the ease of interest, for the ease of clicking, I already put it here so we can generate some test traffic, right? So now let's generate some test traffic. We'll go to box. We'll click on log in here, even though I'm not going to. I'm going to do a couple of these so to get some traffic. Similarly, I'm going to do a couple of these. And just do one that don't have any, application to identify, any ACL to identify the application, Amazon, for example, right? Okay. So I think that would allow us to see some traffic. So let's navigate. This is all external traffic for now. We'll test internal a little bit later. Okay. We'll navigate it back to the unified events here, right? And then here, what we can do is we can filter based on the web application, right? We'll identify box. We'll identify Dropbox. We'll identify Facebook, Instagram, WebEx, and Zoom, right? We'll apply that. Okay, and then we'll go back to maybe the last 30 minutes here. And you can see the traffic that we generate is here, right? Now, as I mentioned, it might take a little bit of time for all the traffic to route correctly because we need to learn about all the domains associated with the IP addresses and etc., right? But you can see here, you can use this interface here to observe the behavior, right? So right now, the default behavior is load sharing, right? We haven't really primed off the database yet, okay? And we can tell by going back to this interface here, and let's refresh that. And you can see here, we haven't learned and populated information here yet. It will take just a little bit of time to build that up, right? So please be patient, right? Because it does take a little bit of time. Right, let's just try to generate some more traffic here real quick. So I'm going to X out of this and then just go through another route here. All right, let's see if we can see some. Still have not seen it yet, right? And let's just go back here real quick to see if. So you can see here some of the traffic started to polarize here to one interface versus the other, right? Dropbox is one as we expected, okay? All right, so that is the external applications. Let's test the internal applications real quick and look at it, and then we'll go back and to see if, you know, the database have been built up and then the display will display. Before we do that, let's also do this command one more time to see if path monitoring started seeing, yeah, it started seeing some information about Facebook here, as you can see, okay? But it does take a little bit of time for the UI to catch up, okay? But on the FTD platform itself, it started seeing Facebook now, okay? Some applications we found that works a little bit quicker than the others. It's just the nature of how many domain these applications have and so forth and so on that we need to learn about it, okay? So let's go back to our client here and let's bring up the interface, I mean the web browser again, and let's just test the internal DNS server, for example, right? Generate a couple traffic go into the New York hub site. And let's just go ahead and do SSH just so we can see a couple things going on. Not going to log in. Okay. All right, let's go back to over here. Right, and now let's take these out for now. And now we're going to want it to match based on source and destination IP so that we can see it, right? So we'll do a source source IP, right? And the source IP is going to be 1072.120.50. Okay. We wanted to do a destination IP. Okay. And in this case, it's going to be 10.100.0.5 is our server. And we'll apply that. We'll go back to the last maybe 5 minutes. And you can see here, SSH is low share between the interfaces. In this case, I haven't seen the other one yet. It should be outside one and now. I mean, the VTI 1 and 4, you can see here. Okay. One and 4. Okay. Now let's do one more thing before we wrap it up for the demo. Let's go back and see if we see the refresh here to see if it still haven't show up here. WebEx still haven't, I mean, the Facebook haven't show up here yet. Let's refresh this real quick. There you go. Now, these are the metrics that we derive by going all the way to facebook.com, right? And learn about jitter, round trip, and packet loss and calculate the Morse score, right? And you can see here, this is going to be very dynamically. Here you see these are the point that we collect information. As Genius mentioned, the HTTP props or HTTP ping is once every 10 seconds. And for my reading, the calculation is based on the last 30 samples for the average, right? So it does take a little bit of time for all of this to populate and etc. Now for ICMP, the ping is more frequent, once a second, and we can get more information. I mean, you can see more test point here, right? So with that, I want to say thank you very much for your attendance. We hope that you found this to be useful, and we hope to see you in the upcoming webinars where we're going to show you how to integrate with cloud-based security services such as SASE and SSE. From a Cisco naming perspective, SASE, we use Cisco umbrella integration with SD-WAN to become part of SASE solution. And a more recent offer we just came out called Cisco Secure Access, which is our implementation of Secure Service Edge or SSE. All right. So with that, Carlos, I'm going to turn it over to you, sir. Thank you.
Thank you very much, Young and Dinesh, for this great session and sharing your knowledge and expertise with our audience. I hope that everyone found great value in today's presentation. Before we wrap up, Dinesh, Young, do you have any closing thoughts for our audience?
Nope. So we'll look forward for the fourth webinar where we're going to talk about the SASE solution. And yes, if there are any questions, please feel free to reach out.
Awesome. Thank you. Young, did you want to say something?
No, I just want to say thank you. We hope to see, the audience coming back for the next webinar on SASE and SSE.
Yeah, same here. All right. And if you missed the previous sessions, the post-event discussion thread will list the previous session along with today's session. I've uploaded the slide deck already on there, so you can download a copy. And then after today's session ends, you can actually review today's session as it is being recorded immediately. That link will be in that post-event discussion thread. I do want to cover some other items before we wrap up. Join us on March 20th as we'll be exploring deploying cloud-based security solutions. If you haven't already done so, please register to receive email reminders and easily add this session along with the others to your calendar and be notified of the recordings on demand. You can scan that QR code that should show up on your screen. I believe it's on the top right or left corners. And yeah, definitely. Lastly, we just launched the survey on Slido, and we would be grateful if you could take a moment to complete it and let us know how you liked today's presentation. We always look forward to receiving your valuable feedback. Thanks again to our presenters and to all of our attendees, our panelists for joining us live today. I hope that you all have a great day, and we will see you next time. Thank you.